which is used for
Globalization has opened the doors of economic development for so many countries. There is a serious concern regarding how far we are being able to save the environment without hampering its constituents. India holds world's second largest road network in terms of length. Roads are considered as lifeline of the nation and an important prerequisite to accelerate economic growth.
Roads serve as the lifeline of trade and economy. India holds world's second largest road network in terms of length. Besides that, under Government of India's ambitious road development program such as Bharatmala and National Highway Development Program, massive road development will be carried out in upcoming decades.
Iron and steel industry are pillars to a country's economic and infrastructure development. India produces about 110 million tons of steel annually and poised to achieve 300 million tons steel production by 2030. Along with steel, about 19 million tons of steel slag is generated every year during the refining process of steel from different steel plants situated across India. For every ton of steel produced, about 20% steel slag is generated. Most of the slag are dumped in the nearby areas of steel plants, which becomes the source of water, air, and land pollution.
steel slag is a major waste of steel industries. Currently, the total steel slag of different steel industries is around 19 million tons, which is expected to grow to 60 million tons per year in the year 2030. So CSR CRI has taken up this R&D project sponsored by Ministry of Steel along with the 4 industrial partners, ArcelorMittal Nippon Steel India, Tata Steel, JSW Steel, Rashtriya Ispat Limited to develop steel slag road technology where the steel slags of different blast furnaces are processed for the development of steel slag aggregates, which is used for road construction.
Every year, multi-billion tons of natural aggregates are used in the construction and maintenance of road network in the country. The idea of environmental conservation gains real momentum if we can conserve natural resources and use them in a manner that they are sufficiently available for the coming generations as well.
ArcelorMittal Nippon Steel India, under CSIR-CRRI technological guidance and supervision, has shown that processed steel slag aggregates can be used for construction of durable roads, thereby providing a cost-effective and eco-friendly green alternative to conventional road construction materials.
Steel slag, which is rich in iron content, can become the source of good quality steel slag aggregates for potential utilization as substitute of natural aggregates in road construction. Despite that, a large amount of steel slag generated from steel industries is disposed of in stockpiles today. As a result, a large area of land is being sacrificed for the disposal of this useful resource. The concept of sustainable development thereby comes into play.
Utilization of processed steel slag aggregate as substitute of natural aggregates in road construction has shown quite promising results. Recently, CSIR Central Road Research Institute along with ArcelorMittal Nippon Steel India has constructed a 1 kilometer long 6-lane bituminous road at Hazira, Surat using processed steel slag aggregate.
Iron ore is sourced from mines and sent to steel plants for first making iron out of it. In the form of pellets, sinter or lumps, the ore is reduced in blast furnaces or DRI plants to form hot metal or sponge iron. This is a raw material for steel making process. During steel making, flux is added to catch the impurities.
Vanakkam, good afternoon, Adab. When we face challenges, we try to search for solutions. When we search for solutions, ideation happens. When we research on ideations, then the development, the innovation takes place. We, at this last day of 11th edition of IESS, organized by EPC India and equally supported by more than 300 exhibitors, showcasing their excellent technological solutions which has come when they faced a lot of challenges which has been given by the client to them, the solutions which has been manifested in the form of a lot of technological development has been exhibited in this particular fair. So we have today come across to showcase such an exquisite development in the area of utilization of a waste. As you know, the concept of converting waste into wealth has been the very important principle for the industrial experts and for creating benefit to the society. So this is one of such exemplary experience which has been contributed by none other than CSR Lab, Central Road Research Institute from Delhi. We have with us brilliant scholars, scientists, innovators with us who will enthrall all the audience with their innovations, with their excellent work, the detail of which I leave it up to them to explain to you. And such an important program which we are having right now, to rekindle and to kick off such program, you must appreciate the inspiring effort which has been there behind this program by none other than our beloved chairman of AEPC, Mr. Arun Kumar Garodia, who has incessantly persuaded me to really look upon this particular issue and to bring forth to all the participants, to all the audience, to all the foundry manufacturers, to all the steel manufacturers who are facing huge amount of problem to dispose of this slag, which is a nuisance, which is is a nuisance to the society, nuisance to the environment, and how they are utilizing the transforming the slag to a very fruitful association, fruitful benefit for the useful to the society. They are going to explain. I now request our chairman, sir, Mr. Arun Kumar Garodia, to come up the stage and give the inaugural program to enlighten everybody. Please, sir.
Good afternoon, friends. My special welcome to Dr. Manoranjan Parida, Director CSIR CRRI, Dr. Satish Pandey. A very hearty welcome to esteemed participants, delegates and dignitaries gathered here for the flagship event of EEPC India, the 11th edition of the International Engineering Sourcing Show, IESS 11. It is indeed a privilege to inaugurate this significant seminar focusing on the utilization of steel slag in road construction, waste to wealth concept. I am thrilled to witness the convergence of industry expert, innovator and thought leader, Dr. Satish Pandey and Dr. Manoranjan Parida. Of course, they are the experts and they will deliberate on the sustainable solutions. Today's discourse is particularly crucial as we delve into transforming byproduct steel slag into a valuable resource for road construction. This aligns with our commitment to foster environmentally conscious practices and contribute to waste to wealth concept. CSIR CRRI is taking a pioneer role in using of steel slag for construction of road, especially in those areas where lasting of the road made by the conventional style is a big challenge. Dr. Satish Pandey, principal scientist, has been actively involved in research of suitable aggregates made from raw slag obtained from steel manufacturers, is used in various combinations in the different layers of road construction. This has found to have significantly higher load-bearing capacity, resistance to abnormal wear and tear, reduces vehicle accident and maintenance, and also much cost-effective. Recently, he has taken a pioneering role in construction of a 1.2 kilometer 8-lane road in Surat, completely made with steel slag aggregates. That's wonderful. Under the concept of waste to wealth, the steel slag, which was considered as a byproduct waste from the steel industry, is now regarded as an important product to be used in a much beneficial and cost-effective application for our society. In the pursuit of sustainable development, it is imperative that we explore innovative avenues. This seminar serves as a platform to share knowledge, exchange ideas, and collectively pave the way for a greener and more resourceful, efficient future. I encourage each one of you to actively engage in the discussions, fostering collaborations that transcend boundaries and contribute to the prosperity of our industry and our planet as well. Thank you for your presence, and I'm confident that the deliberation during this seminar will chart a course towards a more sustainable and prosperous tomorrow. My best wishes for a fruitful seminar. Thank you very much, sir.
May I request Director of CSIR, CRRI, Dr. Manoranjan Parida, to come up the stage and say a few words about the institute and the work he has been doing.
Good afternoon, everyone. We are in Coimbatore, so Vanakkam, Namaskar. It's a great pleasure to be with you. I am Professor Manoranjan Parida, Director, CSR Central Road Research Institute. We are one of the 37 CSR laboratories in the country. And Central Road Research Institute was created way back in 1952, 5 years after independence. The institute has been in the forefront of research with respect to highway development. Although our name is road research, but then we work also sometimes on railways, on airports. We prepared the feasibility study for Delhi Metro and currently doing studies for airfield pavement management system. In terms of usage of industrial waste, the fly ash mission started 96, but the basic work of utilizing fly ash for highway embankments, approach to the bridges, was taken up by Central Road Research Institute. We had the opportunity to be part of such prestigious projects, and today, while Mr. Satish Pandey is going to give a detailed account of the steel slag for the utilization of road construction, I say that the CSR is chaired by Honorable Prime Minister. There are 9 national missions. Waste to Wealth is one of the national missions, and under that CRI has given a mandate for usage of various industrial waste. Steel slag is one of the waste. Currently, we are doing a project on red mud, that is from the alumina industry. We are doing project on zinc slag, copper slag, fly ash I have mentioned, and we also work on waste plastic, using municipal solid waste, construction and demolition waste. So all these waste materials we have been working on. Initially, they were at the lab, but many of them we have been able to roll out. Largely, we get a good opportunity. We have a very excellent interface with Ministry of Road Transport and Highways, Indian Roads Congress, Bureau of Indian Standards, Border Roads Organization, NHIDCL, even state governments. I'll give just an idea. For the government of Orissa, we are doing 70 crores rupees project, consulting project for bridges, for maintenance of roads and road safety audit. So that's how we work pan-India. Our projects are in Arunachal Pradesh, in Kerala, Trivandrum. So we are spread all across. But without not taking much time to come into this particular theme, where it is very important is that these steel slags are substitutes of natural aggregates. Currently, I visited Russia, and the Russians are looking at us very, very closely. So one point they also highlighted, that our road network is the second largest road network in the world. So we are next to US, but the pace with which we are progressing, maybe we land up as the largest road network. We have a MOU with the Russian Road Research Institute with respect to the steel slag roads, with respect to bridge management system, road management system. So these are the great opportunities. In the process of road development in many states, personally I was involved for road construction in the state of Bihar. I could see 2 mountains which were wiped off between 2006 and 8. If you look at your natural surroundings, you will find many mountains really going out if you continue to use these natural mineral aggregates. So these steel slag aggregates are a wonderful substitute for the natural minerals which are used for road construction. So it's going to preserve our ecosystem and definitely lead towards a sustainable
or granulated blast furnace slag like that. But nowadays this blast furnace slag is largely utilized in the form of a granulated blast furnace slag in cement manufacturing. So as far as the utilization of blast furnace slag is concerned, it's not a matter of worry to any steel industry, since it goes into cement manufacturing for the Portland slag cement production in the form of ground granulated blast furnace slag, which is generally known as the GGBFS. So GGBFS can directly substitute 40 to 60% OPC cement in cement concrete, and majority of steel plant are nowadays on manufacturing different type of slag cement. But subsequently this hot metal goes into the steel furnace for the production of steel. So based upon the type of furnace deployed into the steel plant, the steel slag can be broadly classified into 3 categories. So First one is the basic oxygen furnace or the LD steel slag. Second one is the electric arc furnace steel slag, and third one is the cone arc steel slag. So these three are the major type of steel furnaces in any integrated steel plant. So if you will see on Pan India presence, so 60 to 65% steel production happened through basic oxygen furnace route, while rest of the steel production happened through electric arc furnace and cone arc furnace route. So electric arc furnace are largely driven by the recycled metal. So the recycled metallic content can be higher, scrap can be utilized in a larger extent, while in cone arc furnace you can use hot metal as well as the recycled scrap inside it. So the cone arc furnace can be converted completely into the hot metal, but that flexibility is not available in electric arc furnace. So the cone arc furnace is an advanced version of electric arc furnaces, and the JSW Steel Dolvi plant, Bellary plant and ArcelorMittal Nippon Steel plant are utilizing cone arc furnace along with the electric arc furnace. So these three type of steel slag has different chemical and physical properties, and there are different type of challenges in order to utilize it for road construction work. As far as the foundry slag is concerned, like steel foundry slag can further be classified into four categories. One is the induction furnace, then electric arc furnace, then rotary furnace, then cupola furnace. So cupola furnace is an age-old technique, but still it is in prevalence in the Chhattisgarh, West Bengal as well as in cluster of Rajasthan. But the majority of them are switched on induction furnace and electric arc furnace for production of in the foundry. So the characteristic of this rotary, induction furnace slag and electric arc furnace slag are very close to the steel slag. But as far as the cupola furnace slag is concerned, it differs significantly from rest of the slag in terms of physical properties, mechanical characteristic and chemical composition. So what are the major challenges in order to utilize the steel slag? So first of all, steel slag as such cannot be utilized for any road construction work. So in the present form, if it is in the disposed as a waste form, then it is not a useful material for the road construction activity work. The major challenge is the volumetric expansion. Due to presence of high calcium oxide content into it, which varies from 45% to 55%, the steel slag exhibit volumetric expansion, which can be in the tune of 8 to 13%. This expansion is very high, particularly in case of basic oxygen furnace or LD furnace slag, but it is very less in case of electric arc furnace and cone arc slag. So it depends upon the type of furnace through which slag is producing, but the volumetric expansion is one of the important factor. So what will happen when you will put this type of slag into road layer, then due to volumetric expansion, this sort of pop out may come on the road surface, which you can see in the yellow circle, or the bituminous layer can get cracked, as you can see in the yellow arrow. So when we put it into water bath at 60 degrees centigrade, then this sort of crack got developed. So no contractor or no road agency will use this type of slag for the road construction work. The second issue is the vesicular structure. So steel slag largely having whites on the surface, very irregular surface, so it is sort of a vesicular texture. It is nowhere equivalent to the good quality natural aggregate in terms of morphological property. So we have to address this issue in order to get it utilized for the road construction work. Third issue is the probability of tufa formation. Since the slag is rich in calcium oxide content, then with the passage of time, the carbonation of aggregate will happen, and this carbonate layer can be formed on the top of a granular layer. So it may impede the drainage characteristic of the pavement with passage of time. So we have to address this issue while getting it utilized for the road. So this sort of corrosion can happen. The fifth issue is the chances of heavy metal and high pH leaching. So this is an environmental concern. So the variety of, like, the different type of steel slag contains different type of heavy metals, and some of them even we found the contain lead, zinc as well as magnesium. Cobalt is also found inside it. So we have to ensure that this sort of heavy metal leaching should not happen into adjoining water bodies as well as in the land surface, and it should not contaminate our environment. Since slag is very rich in calcium oxide, so it also exude high pH leachate. So this pH can be in the tune of 11 to 13. So it can raise the pH of nearby water body and affect our aquatic life there. So what we have done, like we have developed the customized steel slag valorization technologies to convert different type of steel slag as processed steel slag aggregates. So while doing so, we have developed a specified process in order to convert the slag in a good quality road aggregate depending upon the slag type. So there is a customized steel slag valorization technology for LD slag, for electric arc furnace slag with cone arc slag. So by doing so, like we maximize certain type of mineralogical phases in the slag so that it can give a good quality, can provide a good quality natural aggregate which is even better than the natural aggregate available for the road construction work. So this is the glimpse of the processed steel slag aggregates. So it is very angular in nature and free from any vesicular structure, and there is no volumetric expansion into it. So this aggregate in terms of morphological properties, physical properties and chemical properties is even better than the natural aggregate, and it is available at around 1/3 cost to the natural aggregate. So with the help of it, like the road contractors are getting it utilized for the road construction work. Yeah. So this is a glimpse of a steel slag processing methodology. It starts from the controlled cooling in the slag pit to maximize certain mineralogical phases into it. So if this controlled cooling is not carried out, then slag will be largely in amorphous phase. But in order to get it converted into good quality aggregate, the slag should at least have 85 to 90% crystalline structure. So by doing so, we maximize the particular mineralogical phases in the slag. After that, like once it is air cooled, it is transported into the slag yard where the primary crushing is carried out. After the primary crushing, be subjected on the magnetic separation. This is the drum type magnetic separation. So we bring down the metallic iron content in the slag less than 3. Just highlighting the high point. So these are the process involved into the slag processing in order to get it converted into the road aggregate size. So so it's a kind of a customized steel slag processing plant. So this customization need to be carried out depending upon the hardness of the slag, type of slag you are having, and the quantum of slag is available in your facility. So this is a typical steel slag processing plant. For the design, we have given it to ArcelorMittal Nippon Steel, and they have implemented in their plant for the production of steel slag aggregate. So it's a combination of multi-level crushing, at least 2-stage crushing is there. Besides that, multi-level magnetic separation is there in order to bring down the metallic iron content and to maximize the metal iron recovery from the slag, which is a quite benefit. The steel industry can reap out major benefits out of it by recycling those metallic iron into the furnace. Afterward, like we carried out the TCLP analysis. This is called toxicity characteristic leaching procedure through US EPA protocol. So under this particular ICPMS technique, we determine the metallic iron content, possible metal, the heavy metal leaching out of the slag. So once that slag is treated through the above process, it is found completely safe for different road application. So it is complying the US EPA requirement, and these requirement is now even the part of the national guideline for slag processing and utilization in road construction. So in case if any steel industry want to sell the aggregate, they need to ensure that their aggregate is complying this requirement before supplying it for the road construction work. Now another test is the volumetric expansion test. So once we have converted the slag aggregate, we tested it for the possible volumetric expansion as per the European standard. So this facility is under our Center for Research on Steel Slag at CRRI. So we found that this volumetric expansion of the treated slag aggregate is less than 3%, and then it can be utilized for the road construction activity purposes. It's taking time, it's better you can switch in the next slide. So this is the mineralogical phase analysis we carried out using XRD method. So we maximize the Larnite mineralogical phase in the slag in order to convert it as a good quality road aggregate. Next. So this is a typical chemical composition of different type of steel slag generated from 3 types of furnaces. So if you can see in the BOF steel slag, the CaO, calcium oxide content is around 50 to 52%, while in the Konark as well as an electric arc furnace it is comparatively less. So the basic oxygen furnace or LD furnace steel slag shows high volumetric expansion in the tune of 10 to 12%. The major difference in terms of chemical composition in natural aggregate and slag aggregate is the content of silica. So the natural aggregate is primarily siliceous in nature, since the silica content is around 33 to 35%, while the steel slag is considered as a calcareous aggregate, since it is rich in calcium oxide but devoid of silica. So in terms of chemical composition, the slag aggregate differ considerably than the natural aggregate. Next slide. Now, like this is the another thing, like once in like if we cannot do the controlled cooling, so if the possible in the possible modification in the slag pit is not possible, and you have the old stock of slag or the legacy slag inside the plant, then we can do the surface modification of slag in order to make it completely water-phobic in nature. Click it on this particular photograph, one video will run. Yeah. So this is the LD slag aggregate. So if you can see, it is absorbing water. So this water absorption was higher than 2%, so it cannot be used for the road construction purposes. Now we carried out the surface modification, and this aggregate become completely water-phobic in nature. So in the next video you will see that, like when we would put this water droplet on the top of the aggregate, this aggregate will not absorb any sort of moisture. So there is no moisture absorption, water absorption in the slag aggregate. So it's become completely water-phobic in nature. So in this scenario, like this aggregate can be directly utilized for road construction work. If you want to avoid this surface modification, then we have to do the controlled slag cooling in the slag pit. So that can only be done when the slag is in molten form. But once the slag is solidified, or you have the legacy stock, then in order to control this vesicular structure and the water absorption, this surface modification can be done. Next slide. Next slide, next slide. Yeah. So after doing all these things, we constructed couple of roads in India utilizing processed steel slag aggregate as an 100% substitute of natural aggregate. So for the construction of any road, the 95% volume of the road is occupied by the aggregate only. The 5% is only the bituminous binder, which you can see on the top of the black top road, but rest of the layer is only comprises aggregate. So for a 1 kilometer 6-lane construction, 6-lane road construction, around 80 to 85,000 ton aggregate are required. So we substituted all those aggregate with the processed steel slag aggregate for the construction work. Next slide. So this is the glimpse of the first steel slag road which we built at Surat Hazira. Click on this video, it will run. Surat Hazira, it's a 6-lane long 1.2 kilometer road connecting NS6 to Hazira port. So we have utilized around 1 lakh ton processed electric arc furnace steel slag aggregate as an 100% substitute of natural aggregate for this road construction. Around 3,000 to 4,000 commercial vehicle per day are utilizing this road, carrying 30 to 40 ton payload on it, and this road is completely in sound condition. This road was constructed in April 2022, and last 2 years we are continuously monitoring its performance. It's an instrumented test section comprising strain gauges, deflection gauges and all. So this road is built with 32% less thickness in comparison to the conventional road. So whatever the Indian Road Congress guideline specify the road thickness for this type of traffic, in comparison to that we built this road with 32% less thickness, which rendered it around 40% economical than the conventional road. The next slide. So this is a glimpse of the structural composition which we have utilized for the construction of this road. So there is a 32% reduction in the overall road thickness when we constructed it. Next. We carried out its in situ structural performance evaluation with the help of heavyweight deflectometer. So one of the important finding is that, like the conventional road which were giving the deflection of around 996 micron at 140 kilonewton load, In the case of steel slag road, this deflection get reduced to 385 micron. So there is increase in the stiffness of road by at least 3 to 4 times, which makes it sort of a perpetual pavement which will not require any sort of major maintenance work for 20 to 30 year time. So this is the major benefit. The another project is NS66 Mumbai Goa. So this is in front of the JSW Dolvi plant. So on this particular project, we constructed cement concrete steel slag road and the bituminous steel slag road at the same location. So on LHS carriageway, you can see the cement concrete steel slag road, while on RHS it is a bituminous steel slag road. So in this particular project, we have utilized 80,000 ton Konark steel slag aggregate as an 100% substitute of natural aggregate. So one of the innovative feature of this road is that, like, along with the slag aggregate, we have utilized slag cement. So there is slag aggregate and slag cement for the construction. There is no natural aggregate inside it. So this is a NHEI project which we have constructed, and it is completed in March 2023. And since then it is performing very well. So it is main carriageway of connecting Panvel to Goa. So in this particular project, we have reduced around 28% thickness in the overall road layers. So once again, it is proven to be an economical, around 35 to 38% cost saving is there by utilizing slag aggregate and slag cement. So in terms of physical and mechanical properties, this processed steel slag aggregates are found even better than the natural aggregate. So these are the different properties parameters specified in MORTH specification for the natural aggregate. So we have carried out the comparative study. So our processed steel slag aggregate are satisfying all the limits prescribed into the MORTH guideline for the utilization purpose. So this is a glimpse of the construction work of NS66 Mumbai Goa. We have utilized best type hot mix plant for the preparation of bituminous mix using slag aggregate. Subsequently, we carried out once again the structural evaluation on this road, and once again we found it around 1/3 reduction in the overall deflection in the road constructing using slag aggregates. So one of the important major finding of this particular project is that, like, since we built the cement concrete road, so cement concrete section was designed for the M40 grade concrete. So the compressive strength of the cement concrete mix should be M40, but when we extracted the core from the road layer, we found the strength between 47 to 54 MPa. So it is even higher. And while constructing this road, we reduced the cement content by 30 kg per cubic meter. So in place of ordinary Portland cement, we utilized the slag cement, that too with the reduction of 30 kg per cubic meter. So there is a significant saving in the case of construction cost. And yeah, next slide. So this is once again a data of a structural evaluation. Next slide. Yeah, click it on it. So this video is showing the aerial glimpse of the road of NS66 Mumbai Goa. Yeah. This is 1.5 kilometers, sir. Yeah, it is going in slow mode. It's not in normal mode. Reclick it once again, stop it and reclick it. Back, go back. Yeah. Now play. Yeah. It is with sound. Your system is not supporting. So on this LHS carriageway, this is a cement concrete road, while on RHS side you can see the bituminous steel slag road. So both the sections are built through slag aggregate only. So this concrete section is with slag aggregate and slag cement, while the bituminous road with slag aggregate and bituminous binder. So it is just in front of the JSW Steel Dolvi plant. Yeah, next slide. The third road which I would like to show you is the Indo-China border road at Zero, Arunachal Pradesh. This section we built it along with Tata Steel Jamshedpur. So the processed LD slag aggregate is utilized at Zero Valley at Arunachal Pradesh by Border Road Organization under our supervision. So on this particular project, this slag aggregate is utilized for the construction of bituminous overlay. So what was the intention of constructing this road at such high altitude area? Like on this location, there is a problem of high rainfall and very low temperature condition, due to which this road is get deteriorated, and regular road get deteriorated in every 3 to 4 year time. Now they built it with the slag aggregate, this surfacing, and expecting the service life of 8 to 10 years. So this slag aggregate was transported via railway rack from all the way Jamshedpur to Itanagar, and then from Itanagar to Zero Valley through trucks, and after that this construction was completed. So the section was visited by the Honorable Member Niti Ayog, Dr. V.K. Saraswat, and he appreciated this technology while doing inspection of it. Next slide. So this is a glimpse of the road which we constructed at Zero Valley, Arunachal Pradesh, using LD slag aggregate. Next slide. Now these are the different steel slag road projects which has been completed so far under CSIR CRRI technological supervision and guidance. So National Highway Authority of India has already started utilizing the slag aggregate and construction of steel slag road, and NH53 at Gujarat and NH53 section and Maharashtra are completely going to be built up with the steel slag aggregates. Next slide. Now, what are the major benefits of it? Like we can reduce the overall road thickness by 30 to 40%. It is directly saving 80,000 to 90,000 tons of natural aggregate for per kilometer construction, 6-lane road construction. So we are conserving our nature by reducing our reliance on natural material for road construction work. There is a cost saving also. So if you are constructing this road in 100-kilometer periphery of a steel plant, then there is a significant cost reduction of around 40 to 45%, since this process slag aggregate is at 1/3 cost, and besides that you are reducing the road thickness. That too with the improved durability and life expectancy. So overall reduction in the cost will be around 40 to 45%. It has improved durability to 4 to 5 times. It has a negligible maintenance cost, and at the same time we can also reduce the greenhouse gas emission, since there is no quarrying, mining, crushing of natural aggregate is involved. It is directly the waste to wealth concept. It's a industrial waste derived aggregate. So we are eliminating the problem of solid waste disposal inside in and around the steel plant and utilizing it for the road construction work. So it's a sort of a cheaper economical option of natural aggregates for road construction work. So Honorable Prime Minister of India has also appreciated our effort of Border Road Organization project, which we built it at Arunachal Pradesh, and in a message to CSIR, written message to CSIR, he appreciated the technology and asked us to provide a 5-year vision plan for the implementation of this technology on pan-India basis. So we are developing a web GIS portal for the mapping of slag aggregate, process slag aggregate in different steel plant, which can be directly utilized by the road agencies for the construction work. Next slide. This is the glimpse of the NH33 Jamshedpur road section. So in this particular road, the 40-kilometer road length 6-lane road has been constructed using slag aggregate. But in this particular project, we utilize this aggregate as a substitute of natural aggregate in granular layers. So underneath the bituminous layer, there is a granular layer. So in that we have utilized this slag aggregate, and it was completed in 2016-17, and since then it is performing well. Next. We received the Scotch Gold Award for the environmental and sustainability along with the Tata Steel MD Shri TV Narendran. So he also appreciated our effort in this direction. Next. We received a couple of appreciation letter from the member Niti Ayog, Dr. V.K. Saraswat, CEO AMNS India, Tata Steel MD Shri TV Narendran. Next. So we have published a scientific movie on steel slag road, which I will show you after this presentation, and there is a webinar is also available, online webinar copy is also available on YouTube. You can access it and find out how this conversion can be carried out. Next. So that's all from my side. Thank you very much. And so I would now you can run the movie, and after that I can take few questions. So through the movie you can just have an idea about our work. अभी आप मूवी रन कर रहे थे ना पहले? Mr. Oman, Dilip Oman, yeah. So it was inaugurated by the then Steel Minister Shri RCP Singh. आप डेस्कटॉप पे ही कॉपी किए हुए थे.
Globalization has opened the doors of economic development for so many countries. There is a serious concern regarding how far we are being able to save the environment without hampering its constituents. India holds world's second largest road network in terms of length. Roads are considered as lifeline of the nation and an important prerequisite to accelerate economic growth.
Roads serve as the lifeline of trade and economy. India holds world's second largest road network in terms of length. Besides that, under Government of India's ambitious road development program such as Bharatmala and National Highway Development Program, massive road development will be carried out in upcoming decades.
Iron and steel industry are pillars to a country's economic and infrastructure development. India produces about 110 million tons of steel annually and poised to achieve 300 million tons steel production by 2030. Along with steel, about 19 million tons of steel slag is generated every year during the refining process of steel from different steel plants situated across India. For every ton of steel produced, about 20% steel slag is generated. Most of the slag are dumped in the nearby areas of steel plants, which becomes the source of water, air and land pollution.
Steel slag is a major waste of steel industries. Currently, the total steel slag of different steel industries is around 19 million tons, which is expected to grow to 60 million tons per year in the year 2030. So CSR CRI has taken up this R&D project sponsored by Ministry of Steel along with the 4 industrial partners, ArcelorMittal Nippon Steel India, Tata Steel, JSW Steel, Rashtriya Ispat Limited, to develop steel slag road technology, where the steel slags of different blast furnaces are processed for the development of steel slag aggregates, which is used for road construction.
Every year, multi-billion tons of natural aggregates are used in the construction and maintenance of road network in the country. The idea of environmental conservation gains real momentum if we can conserve natural resources and use them in a manner that they are sufficiently available for the coming generations as well.
ArcelorMittal Nippon Steel India, under CSIR CRRI technological guidance and supervision, has shown that processed steel slag aggregates can be used for construction of durable roads, thereby providing a cost-effective and eco-friendly green
Iron ore is sourced from mines and sent to steel plants for first making iron out of it. In the form of pellets, sinter or lumps, the ore is reduced in blast furnaces or DRI plants to form hot metal or sponge iron. This is a raw material for steel making process. During steel making, flux is added to catch the impurities present in iron during the primary refining process. The flux along with impurities form a semi-refining process. The flux along with impurities form a semi-molten mass called slag that floats on the liquid steel in the steel making furnace. Slag is a mixture of oxides formed by silica, alumina, calcium, magnesium and iron predominantly. The purified metal is taken out from the bottom and slag is taken out from the top of the furnace. The molten slag at 1500 to 1600 degree temperature is poured into the slag pits for cooling. A customized cooling process is developed by CRRI to control and develop microstructure to slag that work as stable aggregates. Once cooled, the slag is crushed into smaller sizes. Large chunks are broken by balling crane where large steel balls are dropped on the slag boulders to break them down. The finer slag is then passed through a metal recovery unit where large magnets separate the entrapped metal pieces in the slag. The non-magnetic slag is then crushed and screened to various sizes based on application. Quality of the aggregate. X-ray diffraction analysis of processed steel slag aggregates is carried out for mineralogical phase identification and compositional analysis. Processed steel slag aggregates developed through controlled cooling process shows the crystalline phases as found in good quality natural aggregates obtained from igneous rock groups. Chemical composition of steel slag aggregates in oxide form is determined through wave dispersive X-ray fluorescence spectrophotometer. Processed steel slag aggregates are also tested using inductive coupled plasma mass spectrometry to rule out the possibility of any heavy metal leaching under adverse environmental conditions. TCLP study conducted using ICP-MS technique showed that processed steel slag aggregates are safe for various road applications. Physical and mechanical characteristics of steel slag aggregates are established through a variety of tests to assess its suitability as road construction material. The CSIR, Central Road Research Institute Research Laboratory used world-class testing facility for aggregates testing. Its most important properties are grain size distribution, resistance to crushing, abrasion and polishing. The volumetric stability of the slag is also verified by an expansion test. Mechanical characterization of asphalt mixes prepared using processed steel slag aggregates are carried out through the state-of-art testing facility comprising Marshall stability, indirect tensile strength determination, and rutting resistance. Brazilian modulus of steel slag asphalt mixes is also determined to design the steel slag road for different axle loads and traffic conditions. Scientists at CRRI have investigated the use of steel slag as an aggregate for bituminous road construction. The best management option for this byproduct is its recycling as road-making aggregate. In India, Surat has become the first city in the country to get a processed steel slag road built as part of a joint venture project between CSIR, Central Road Research Institute CRRI, Union Ministry of Steel, government think tank Niti Aayog and ArcelorMittal Nippon Steel India at Hazira, Gujarat.
Around 1 lakh ton processed steel slag aggregates has been utilized as a 100% substitute of natural aggregate and good earth for construction of this road. This road connects NS6 to Hazira port and subjected on heavy commercial traffic. For last 1 year, CSIR CRRI is monitoring its performance and we found that this steel slag road is meeting all serviceability parameters as specified for national highway in India.
Processed steel slag aggregates offers better mechanical load resistance, leading to reduction in thickness of various road layers. Steel slag road at Hazira is built with 32% reduced thickness for 100 MSA design traffic and 20 years design life period.
ये जो रोड का निर्माण हो रहा है जो धातु मल से, स्लैग से, कॉस्ट वाइज भी अगर देखिएगा तो 32% से 34% कम अभी है, और आगे अगर और रिसर्च होगा तो 40% तक पहुंच जाएगा। इसकी जो ताकत है, जो इसकी शक्ति है, वो भी जो हमारे और रोड बनाए जाते हैं उससे बेटर है।
And I believe that we must look at alternative forms of steel making, such as making steel from steel scrap, such as the example that we have seen of the 6-lane highway that was built with steel slag in Surat in Gujarat, the first of its kind in the world. And that happens only in India, made in India, ladies and gentlemen.
Or maybe India is now, today, formally entered into an era of steel roads. From concrete roads to steel roads, I think a matter of great celebration.
We have in the past pioneered in several new initiatives, one of which was the steel slag road technology, where we utilized the waste steel slag in road construction, highway construction very effectively and made it much more durable, in a way meeting the circular economy principle from waste to wealth.
Structural capacity of steel slag road is determined through heavy weight deflectometer test. Vertical surface deflection response of steel slag road under variable impulse loads are recorded through set of geophones. Surface deflections in steel slag road under identical impulse loading conditions are found to be 60 to 70% less than the deflection observed in conventional bituminous road. Temperature effect. Steel slag road is not expected to have higher surface temperature during peak summer time. CSIR CRRI monitored the surface temperature of steel slag road and found that the surface temperature of steel slag road is as equivalent to conventional bituminous road. Benefits. The utilization of waste steel slag for road construction reduces pollution created by heaps of waste dumped near steel plants. The particles of steel waste also get into the air and even seep into the ground, reaching the underground water table.
For construction, maintenance and rehabilitation of road network, huge quantity of natural aggregates are required every year. This demand is meted out through the unsustainable quarrying of natural aggregates in many areas, leading to desertification and other serious ecological and environmental impacts. I would like to congratulate CSIR CRRI for developing this innovative solution for utilization of processed steel slag in the construction of a steel slag road, which not only reduces the environmental impact of this waste material but also preserves our ecological system by meeting out the partial requirement of the natural aggregates.
The CRRI will now prepare guidelines and specifications for the utilization of steel slag in road construction. The parameters and performance indicators will be incorporated in the road guidelines and will be given to Indian Road Congress, Ministry of Roads and Highways to utilize steel slag for the constructions of national highways.
This technology has been used by CRI for construction of roads in Surat, Gujarat, in Jamshedpur, Jharkhand and Dolbi, Maharashtra.
Utilization of steel slag as substitute of natural aggregate in road construction is a green initiative under the Government of India flagship program Clean India Mission and Waste to Wealth.
Research has shown the possibility of using steel slag in road infrastructures in order to promote the objectives set out by the Sustainable Development Goals to promote the circular economy and sustainable infrastructure. CSIR CRRI's innovative first steel slag road in Surat, Hazira has further motivated us our vision for a greener India, for a sustainable India, for a rising India. Steel Slag Road. A sustainable green utilization of steel slag in road construction.
from our side. So if you have any technical question, we can quickly take. Yeah, please.
Established.
Yeah, for the foundry slag, like we need to adopt the cluster approach. Since in a particular foundry, the slag generation will be around 30 to 40,000 ton in a year, not more than that. But if you can join a cluster, then we can have a good quantity of slag for the conversion into aggregate and then its utilization for road. As I showed you in movie, for a kilometer of road construction, 60 to 80,000 tons slag aggregate is required. So if someone is carrying out the construction of road from bottom to top, then this is the quantity. But if in case if there is any rehabilitation work like bituminous surfacing is required to be carried out, then it will require 3,000 to 4,000 ton for a kilometer road. So in that way, like if there is a cluster approach and 8 to 10 foundries are clubbing their slag together, and I made a presentation for the Jaipur cluster, and they are putting a thought to have a cluster approach and develop a centralized facility. So all the foundries can sell their slag directly to the centralized facility converting it and then providing the aggregate to the road construction work. So for the small foundries there will be a single point contact, and for the contractor also there is a single point for the buying of slag aggregate.
We can utilize the slag for our own purpose. So small concrete flooring and all.
Yeah, but that you can always do, but problem is that like the conversion of slag aggregate in a good quality aggregate and all for a sustainable long-term use, whatever I showed you, it is already commercialized. So Tata Steel is selling the product by the name of Tata Agrito, Tata Nirman, AMNS is selling that AMNS Akar. So this processed aggregate is now a commercialized product. It is available in 200 rupees to 300 rupees per ton in the market. Earlier they were incurring this cost for the disposal of the slag, but now they are earning out of it. So this is all about, like, if you can use on by on for your internal purpose, then it is up to you. But if you have the excess amount of slag which you want to give it or want to sell it in the form of an aggregate, then this cluster approach can be adopted.
Yeah, I understand that we need to process the slag and we have to ensure the qualities of the aggregate.
Since the third party
will provide the right quality of the concrete, as you said.
Yes.
It is providing 40 in the range of the strength.
Yeah. So that is since some third party is buying it. So if road contractor is buying it, he must ensure at least the properties equivalent to natural aggregate, and that then after that your slag aggregate should be cheaper also. Either it should be at par or cheaper, then only it will be prompt them to use it. So in order to do so, if there is a centralized facility, then all the foundry slag can be put it there, and from there it can be processed and sell it to the market. And that centralized facility can directly buy the slag from steel foundries, small foundries. So you can directly sell your slag to them. They will process it and sell it into the market.
Thank you, sir. We will discuss with our association and do then.
Thank you. Most welcome.
Satish, you have given a wonderful presentation. We are really thrilled to see all this.
Thank you, sir.
You have really done a marvelous job. I can understand how much pain you all people must have undergone to develop this.
Sir.
It's a wonderful idea to see 40% reduction in the cost.
Sir.
And 8 to times sustainability.
Sir.
It's really wonderful, amazing.
Thank you, sir.
I was suggesting that there are a few clusters in India, like one in West Bengal. Here in Coimbatore also a lot of foundries are there.
Sir.
Probably we can talk to this foundry association people in both the places, and we'll ask them to put up all the slag at one place.
Sir.
So that whatever process has to be done, it can be done there.
Sir.
And then it will come into hundreds and thousands of tons per annum.
Yeah.
Then it could be used as a road construction the way you have explained.
The policy can be made by any localized department.
Exactly.
Now every road or the maintenance work should be carried out with the slag aggregate, and it is available there. So then only this policy decision can be taken by
So
anyone.
if you could go into further detail after you go back to your office, how we can really work upon this.
Fine,
We will
sir.
try to develop these two clusters, one in Coimbatore and one in West Bengal.
Sir.
So these two things, if taken forward, I think lot of menace will get over and this slag will be converted into wealth.
Sir,
So that will be excellent.
we will definitely help
Thank you
out,
so much, sir.
We have prepared, we have IRC SP 121 is for the rural road application. We have prepared one guideline for the processing and utilization of steel slag in road construction as per the direction of Ministry of Steel and Niti Aayog. It's a comprehensive document of, it is going to be released in first week of April. So in the national highway, in the national highway under new technology initiative, the road concessionaire is free to adopt any new and promising technologies subjected it is fulfilling. So in the EPC mode or BOT mode or HAM mode, if any construction work is going on, then as per the present contract document, the contractor has full liberty to adopt any new technology which can offer good durable structure to them, since he is taking the DLP, defect liability of this project. So in that mode, the CSIR CRRI extended the requisite support to the concerned road concessionaire, and they have utilized the technology for the construction work. Since they found it is more economical, the road is going to be durable, and the CSIR CRRI is extending the necessary technical support to them on site to build the road. So it is not merely up to the conversion of aggregate, it is on-site support for the construction of road also. So they are utilizing it. So Diamond Bursa, the 8 lane road in front of the Diamond Bursa NH53 is completely through steel slag aggregate. Indian Express covered that news also, so you can just Google it and found that particular news. Yes.
I have just 2-3 questions. May I ask it?
Yeah, please, Batra Sahib.
Thank you so much for showcasing this wonderful opportunity. My question was, what is the life expectancy of the roads vis-a-vis the conventional roads being built of these steel slag loads?
Yeah, so normally the conventional conventional bituminous roads require an overlay every 4 to 5 years.
That's all right.
So every 3 to 4 years you have to put a bituminous overlay on top of it. But through the accelerated testing, which I showed you in the video, and it is all these sections are completely instrumented section, we found that this steel slag road will not require any sort of overlay at least 8 to 10 year time. Besides that, it will remain completely rehabilitation free in longer run. It will not require any strengthening. There will not be any sort of rutting, since it has very high structural stiffness.
So we can assume the life expectancy without any rehabilitation maybe 10-15 years.
Yeah, 10
or
15
more
years,
than that.
for 10 years you will not require any sort of overlay, or the rehabilitation, like the road strengthening will not be required to be carried out for 30-40 years. It's a sort of a perpetual road.
And how CRI will be, helping out those who are, want to take it forward?
Sir, you can approach us, you can write a letter, Director CRRI is here, you can approach us, write a letter to Director Sir, and we will assist you, extend all possible technological support.
Okay. And one more thing, you have not touched upon the, cost of the project, which the processor is going to put up in any case. Tentative cost,
Sir, it depends upon the quantum of slag you have and the type of slag you have. Now, whatever the work I have done, even during the lunch hour I briefed you, like it is with the major steel plants. So Tata Steel.
Those are the names involved.
1.5 to 2 million tons slag per annum. So for them the slag is of different quality, conversion is of, but for a small foundry like where it is 1 lakh ton or 2 lakh ton per annum is there, for there the plant requirement will be different, processing requirement will be different. Therefore there is no fixed solution, like it has to be customized depending on the plant requirement.
You mean to say it depends on customer to customer and the quantum of the material.
Besides that, the furnace operation also, how much metallic iron content is coming into your slag, what kind of scrap are you utilizing, what sort of heavy metal into it, whether it is vesicular up to same extent or not. Therefore, it requires the customization. So we provided the customized solution for Tata Steel, JSW, AMNS and RINL.
Just one point I would like to add. The technology is in the knowledge of Honorable Minister of Road Transport and Highways, Government of India, and we are following up with the Indian Road Congress. It takes time for the approval, but it's already being used. The National Highway in Gujarat, in Maharashtra, they are already utilizing. The Honorable Minister, the DGRD, Road Development, they are all aware about this. And in terms of hand-holding, I can tell you, at the point of construction, we are there at the site. At least Arunachal Pradesh, both myself and Satish, we are there during the rolling, compaction, everything. So it's end-to-end because while researching, we are also part of the implementation process. In Jharkhand, for 300 kilometers of rural roads, it has been deployed. So typically around the cluster, wherever the steel slag aggregates are produced, within 100 to 200 kilometers, all the highways, they can definitely utilize this technology. Thank you.
So, this is Dr. D. Sanyal.
Sir.
I am now in the director of Texera Enterprises, but I am a former chief scientist of the CSIR Institute, a couple of CSIR institutes. So,
okay. Pleasure to meet you, sir.
As a former CSIR employee, I feel proud to see this kind of development.
Thank you, sir.
Which is quite, applied and quite progressive for the entire country. Now, I have a few questions. A few of them are technical. One is that you showed the natural aggregates. They have about 30+% of silica, which is not there in the other slags. Now, do you think that silica content, if it is enhanced in your kind of synthetic slag-based materials, will that improve the quality of the roads? Or because natural aggregates have been the usual way. Now you are replacing. So enhancing silica, is it a better alternative?
Sir, increase in silica content will reduce the volumetric expansion due to free lime content. But the increase in silica in the through synthetic way is a costly affair.
No, so I tell you why I am asking this. We from our company are looking into certain sustainable solutions. One of them is using agricultural waste to synthesize silica. Now, Now, one related to that, our process is such that it is very cost effective and we can generate good amount of silica, high quality silica. But the question is, you also showed controlled cooling. Controlled cooling is a prerequisite because of the, you said crystallization, improved crystallization. But my basic question is, how does amorphization make it worse? Why amorphization is to be prevented?
Sir, like there is a particular mineralogical phase, larnite, which is a dicalcium silicate.
Yes.
So this dicalcium silicate is found in abundance in igneous rock groups. So I show one photograph. Since you are a scientist, so you can. So this larnite phase is minimal in case of rapid cooling is there.
Right.
So there is no proper larnite phase get developed. So we controlled it in the developmental process. So we maximized it.
Right.
So it makes it completely crystalline. 88 to 99%, 88 to 95% crystalline structure is there.
I fully understand your explanation. Now coming to the point, if somehow some way of contributing to the silica content is found out in a cost-effective manner from again a waste to wealth kind of a manner. And that's
we are looking forward to.
Sir, I have already spoken to your director, sir. He has been kind enough to visit our stall, and I'll keep on interacting.
Fine,
but
sir.
if there is a way to do that, and there are two options that I have. I can make crystalline silica, I can make amorphous silica.
Okay.
The silica part, if we do amorphous, it is less costly.
Okay.
Will that help? That is my.
Got it, sir. Got it. Sir, the addition of.
We'll do that.
Yeah, got
we'll do that.
I'll cut this avenue we never explored.
I'll cut it short with a very last question, nothing to do with this scientific thing. As you said, the cost is 40% less or something. Is there any better, is this process carteling the time deployment of making the road construction time also gets reduced, or is it the same?
it is basically ensuring the availability of alternate aggregates. Sir, during rainy season, there is an acute shortage of aggregates since you cannot do the quarry in the same pace. So this aggregate is a sort of a very readily available material which can be available throughout the year. So therefore, the contractor is utilizing.
So overall, the availability is
as well as the cost also. Like it is cheaper than the natural aggregate.
Hi. Normally we are using the slag powder to make the liquid slag to solid. Then only we will remove the liquid slag from the metal. Okay, it's a slag powder it's a calcium based material. It's normally slag like a pearlite, powder. Okay, we will add it in a practical manner. We will add it, then make it solid. Then only we will remove it and dump into the slag pit. So this is the normal procedure of slag removing in induction furnace. Okay, that slag material we can use it for this.
No, I am not using any slag powder. It is just whatever the slag is coming out from the furnace, it is tapped directly into the slag pot. Then it goes into the slag pit, and there is a process cooling method we have given it to them. We are not putting any slag powder.
Normally in all foundries, so here in Coimbatore or maybe it's a liquid slag. So we have to remove, we have to add that silica powder.
This is for the floating of the metal on the top of the, it happens inside the furnace. It happens inside the furnace, not in the slag pot.
No, in the furnace only. While melting.
In the furnace only. So it is not. It is just you are putting it into the hot metal itself.
Yes.
It is you are putting it into the hot metal in order to skim the metal. That is a different thing. It happens into the steel industry itself. But as far as the slag is concerned, it is the tapped material inside the slag pot.
Okay.
Whatever you are thinking, whatever I am showing in this video, it is the molten slag. Is only the slag. It is not the hot metal. It is the skimmed material from the top of it.
We understood that because for removing the slag, so we are adding that slag powder.
The slag that is added into this, that is a different.
It's a calcium based material.
Yeah, I got it. It is to skim it out.
Yes.
Yeah, that is the.
Okay. So and controlled cooling.
It is like whatever they need to do inside the furnace in order to maximize the slag outcome and all. It is the domain of steel industry.
Okay.
My domain starts once the slag is tapped out from the furnace into pot.
Okay.
Since I am not going into their metallurgy, how to make steel or what quality of steel and all. So whatever the slag they are generating, once it is comes out, then
right,
it is putting it.
But normally, actually, some of the furnace they will tap the furnace, just tilt the furnace, and that liquid slag will be poured into the slag pit. So and normally in our induction melting process, so to remove the slag, we will add some powder, and we will remove the slag. So that material may be calcium based.
Yeah.
Okay.
Yeah, it's a calcium based, so it is called fluxing agent.
Yes.
It is called fluxing agent. So fluxing agent invariably added in all steel furnaces.
Okay. So we can use that.
Yeah, it can use it.
And that controlled cooling. So normally we will dump into the one locations.
सर वो आपके यहाँ फर्नेस फाउंड्री में तो और ही थोड़ा रैंडम होता है. I know it very well. Like उसमें तो बड़े like in case of larger steel plant there is a big size of slag pits are available. There is a slag processing units are there who handle this slag. They bring the slag from the furnace to the slag yard through slag cars.
Yes.
So it is a very controlled process, but as far as the foundry is concerned, it is very random process. So you dispose it always in the form of a waste. There is no valorization is involved into it. So we will help you out to valorize it into the good quality aggregate.
Okay.
Yeah. Yes. Yeah, sir, please, sir. You please go ahead. Sir, Mr. Chandrasekhar is there, sir. Yeah, please, sir.
Sir, good evening, sir. I missed a major part of the thing. Apologies.
Sir.
I'm Dr. Chandrasekhar, convener of
Sir,
Coimbatore
yesterday
chapter.
we met him.
Yes,
sir.
and
Yeah.
I'm also representing the Coimbatore Smart City initiatives.
Sir.
And I'm part of the Coimbatore Road Safety Committee.
Okay,
My
that's
questions
good.
are connected to the road safety engineering.
Sir.
How is it going to impact the road safety design and engineering of the vehicles plying on them? And how are the precipitizers or sharp edge of the slags are going to impact on the tires or things like that? How is water going to impact on these things? This I bring from the application point of view, nothing to do with engineering.
Fine, sir.
So would you please
Fine,
add?
sir. So first question is related to the road safety. So this utilization of steel slag road basically improve the skid resistance. So it is a proven thing, like this road will offer higher skid resistance under wet condition. So if you are putting it on any intercity road, you will get better skid resistance in comparison to the conventional road. Your second question is related to the angular shape, whether it affect the wear and tear. So we converted the slag in the form of a processed steel slag aggregates, which is at par or even better than the natural aggregate. So when you will see the slag aggregate, even you cannot differentiate whether it is a slag aggregate or natural aggregate. So it is just going to be utilized in a normal manner as you construct the road. So it is not going to affect any durability. Third question is related to the water resistance and all. So since the slag is calcareous in nature, it has lime, so it offer very good affinity with bitumen the binder which is utilized for the black top surface. Therefore, there is a very less stripping. The road get deteriorated when there is a accumulation of water on the surface. So this slag aggregate has very high affinity with the bitumen, therefore it will remain pothole free for 8 to 10 years. There will not be any sort of distress. If you are putting it in a high rainfall area, then you can always do the surface modification and convert the slag aggregate waterphobic in nature, as I shown in my video, which we did it at Arunachal Pradesh. So aggregate is completely waterphobic, no water can penetrate inside it, so your road life is going to last 10 to 15, 20 years and so without any kind of maintenance.
I got one question and one suggestion, sir. One question is that Indian Road Congress has accepted it and you have got the standard norms for road laying process, the number of layers, compacting stuff. If it is that, we could let's share of it. And the last one is that since I represent Coimbatore Industries and member of every association here, I invite a lot of people from Indian Institute of Foundrymen. I think one of Kosa is there, but I have invited a lot of people too short of a time. I would invite you again one more time to come to Coimbatore, sir. I will organize a meeting with the Indian Institute of Foundrymen. Coimbatore has got, if not I'm wrong, about 800 or 700 plus foundries. And it could have been a miraculous solution if you kind of give it to us.
Sir, that director sir can give the call, like take the call.
No, thanks for the invitation. DG CSR is Dr. N. Kalai Selvi, who happens to be very close to Coimbatore only. Because of our engagements, he could not join this. So we can come back and we can have a much elaborate session for your cluster.
We'll take up the question. Prior to that, actually, our chairman sir and director sir has to leave for another important appointment, but he will be there to take up all your bullets. Okay, don't worry about that. Can I request chairman sir to come up the stage? We'll have a small rituals to perform. Director sir, can you please come up? May I request Chairman sir to hand over a token of appreciations to Director of CRRI, Dr. Manoj Parida. I'm requesting Chairman sir to hand over this token of appreciation to Mr. Satish Pandey, please.
आपका क्वेश्चन था ये बोलिए. There is very, you can say, active participation from varied road construction agencies. I am going on 21st March at Adani Enterprise headquarter. They want to build this road in West Bengal, Odisha, Chhattisgarh, and intend to sign an MOU with us. Similarly, the L&T has already in touch with us and signed an MOU in this regard. The parallelly GR Infrastructure, the GR Infra Projects is utilizing it in Mumbai-Vadodara Expressway. Similarly, the Megha Engineering at Andhra Pradesh-based company is also utilizing it. So it's all about the availability and the economics. So if someone is getting the slag aggregate nearby of requisite quality at cheaper price, they will use automatically, since it is going to lead towards the saving. So everyone want to maximize their profit without compromising the quality. So if you can provide an alternate which is cheaper and improving the durability, then the contractor will use it. All layers, sir. We utilize it in all layer from top to bottom, from subgrade to all layer using slag aggregate.
How challenging it is to use the foundry grade all this which we are generating from
challenges in the foundry is basically the lack of cluster approach. Since the quantum of slag is very less, so you will not be able to do it valorization on by on. So there should be a good quantity of slag. Since if any road contractor is willing to use the slag, then he require a assurance of availability of 2 lakh, 3 lakh ton slag aggregate. Since once he has decided to use the slag, then it should be available in a good quantity without any restriction. But this type of production in a one foundry is very difficult. So until unless 10 to 12 foundries are clubbing together, putting their facility and showing that like we have 5 lakh ton or 10 lakh ton slag aggregate available, then only it will go in the construction work.
Apart from the quantum of foundry slag, the quality of the slag, there is the chemistry of the slag, has it been tested chemically, that like you showed the composition of electric arc furnace and so many others?
So in the foundry also, the electric arc furnace and induction furnace are two major things nowadays. The cupola and rotary furnace is age old, and so very few are available.
So whatever you showed,
electric arc furnace, it is as par with the things which I have shown you earlier. The induction furnace is also similar in nature, but the pH of the induction furnace is a bit different, so we have studied that also. But the quantum is not available to construct a road and like that. So until unless it is clubbed together, it is not something going to happen.
Thank you.
Thank you, sir.
What I understand from the discussion, that you are getting an enormous response against this.
Yeah, we are extending the support. Like we have received requests from the government of Russia. I am working with MLK Group, largest steel plant in Russia, for the conversion of steel in the slag aggregate and road construction. Similarly, we received a request from the US-based company RPJ and the World Multi-Serve and Hashco Group for the conversion of slag in the slag aggregate. So we are working in USA, UK, and Russia on the same technology.
I just wanted to know, do you preempt any challenges taking it forward?
Challenges.
Any challenges you preempt that taking this
challenges
forward?
Is basically the assurance of the quality, since you might have installed the facility but not processing it in the required form, and then unprocessed slag aggregate is going in the road construction, which can pose any problem and there is a distress. The second issue is that like you may be providing good quality aggregate, but the contractor is not utilizing it in a proper manner, which can cause any failure. So therefore at this stage, neither the contractor nor the producer are fully acquainted with the process.
That
so
process is not well established.
Yeah, so until unless like this skill development happen up to requisite scale, it is required to be monitored under a strict technological supervision. Otherwise, it will fetch a bad name. In place of success story, it may become failure story.
That may become a failure story.
Failure story. So
exactly.
Yeah.
That is the big challenge.
That is the big challenge.
Thank you, sir.
Specific gravity is high. Specific gravity will be around 3.1 to 3.2, while the natural aggregate is 2.8 to 2.84. But with this high specific gravity also, since you are reducing the road thickness, so the volume of the aggregate will be equivalent or less than the natural one. That minimum thickness requirement is not applicable on this technology. We have already even constructed the road which is even less than the minimum thickness and Sir, it happens, but when we are providing the design, CRRI is providing the design, then NHI and everyone is adopting it, and this road is already constructed. It is not something on paper and all. So 3 years we are monitoring the performance, we have good data, and the final guideline is also going to release in first week of April. So it comprises all the thickness reduction criteria and design criteria as well. IRC, like, yeah, they can come up with a separate code, or since IRC SP 121 is also prepared by me, you can find my name there. So the first page itself, that draft is prepared by me, like entire for the application in rural road. So since this project is from the Ministry of Steel, Niti Aayog, so they have taken the initiative. So the committee which is looking after the guideline also comprising the members from the IRC, MORTH and CPCB. So this guideline is coming after an evaluation by a larger body than IRC. Since Central Pollution Control Board is also there, Ministry of Road Transport and Highway there, NHI is there, Indian Road Congress is there, besides all steel industry. So that guideline is even more comprehensive in nature. Thank you. Thank you. Thank you very much. Thank you.
I'll be so much interested to know, and it has been seems to be very successful seminar and very informative. EEPC extends its heartfelt thanks to CRRI Director, Principal Scientist, Mr. Satish Pandey, for giving us precious time and energy to come here and deliberate whatever developments he has done, tremendous development he has done, and that usage of it is really helping the society and all the people across India, and maybe he is going beyond the borders to Russia and other countries and all, because his remarkable feature has been addressed and recognized by international experts. So this is make in India, Atma Bharat, everything booming in one go. Thanks to him, thanks to all the community of industry, and we expect more of this development to happen in future, and more of acceptance of this and application to the industry and the society. Thank you very much.